Good morning, also from my side. We're up there, awesome. I want to talk about basically a bit about architecture, about microservices, about workflow automation, and a couple of thoughts I have because I basically discussed that with quite some customers over the last 1 or 2 years. So the first thing we see, just to give you setting the scene, so microservice is a bit about basically breaking up the monolith. So we have that terrible legacy monolith. You probably remember that from yesterday. And we have a couple of functions, and we want to break that up in more or less independent services. That's what microservices is about. I don't want to discuss the size of the services. I just want to emphasize on that. One of the main goals of these microservices are basically autonomy. So you want to have very autonomous services. So you have, for example, own teams owning them, developing them. They're running on own machines, probably in different languages. They have their own data, so they don't share data. They have to talk to each other in order to do something. And that makes them very, very isolated from each other. And the idea is that you can. No, I basically come back to the idea in a second. So we did a survey earlier this year. You probably even got the link. And there we asked a couple of things also about microservices. And these are the results. So a couple of people said, OK, we are already using microservices, or some of the stuff we do are using microservices, or we at least consider using microservices in future. And if you sum that up, I did the math for you. It's 92% of the people saying at least they consider microservices. So it's quite an important trend. So it's not like an hype. It's kind of on the hype curve probably, but there's some sustainable things in there. So I think it's very valuable to look at least a couple of the things, the values in microservices. And the why of microservices, so there are a couple of reasons, like improved scalability of applications, and I think there are two different things. So first of all, like I can scale up one service if that gets a lot of load. I can scale it up independently, but I can also scale up my developer force because I can have now more teams which develop new services, which is easier to scale. And the second one I think is very important, faster time to market for new products and services, or to support the digital transformation. There are a couple of other things in here. You probably want to look it up yourself. We get the study online. I personally always, I like metaphors, I like simple pictures, so I normally use this picture for the motivation of microservices. This is a so-called three-legged race. So there, the people are bound together by the feet, and then they have to run. It's kind of a game. What you can easily see there is that everybody has to run a bit slower. I mean, it's harder to run if you're bound together, and the risk of falling down is much higher. And microservices, they want to unbind the people, they want to unbind the team, so it's easier to run alone, because then you can run much faster. You can decide to quickly stop, change the running shoes, and then you know, okay, now I'm much quicker, and you can simply do that. And that's the idea of microservice. That's the promise of microservices. But the thing is, now we have all these services. We have a couple of independent services, and we have to get like a full picture out of that. And that's is starting to get the main challenge. So the single service is relatively easy to do nowadays. There are a lot of best practices about how to do that service, and it's small and isolated, so it's easy to do. But how to get something bigger out of that? We still have like big processes. And I do an example. I'm an example guy, and today I want to relate to something I also learned a lot at Zalando. Zalando is one of our customers. They're doing the order fulfillment process, so the core process of Zalando they're automating. And it's not like this, but a simplified version would be something like this, where you could say, OK, I have a couple of microservices. So for example, we have a checkout service where the customer can check out his order. We probably have a payment service where the payment is retrieved, the money is collected. We probably have a shipment service because we have to ship it out, and we have an inventory because we have to collect all the goods. And if you do that, one possible architecture, not the only one, but one possible architecture would be an event-driven one, for example, and then you could use something like Kafka, or probably even Rabbit if you don't have RabbitMQ, if you don't have the load, but they use Kafka, for example, in order to let these services communicate. And if you look deeper into that and looking in how basically such a simple order fulfillment process, like a simplified version there, I want to pay, I want to fetch the stuff and then send it over. If you look at that, how this is implemented in an event-driven architecture, it basically looks like this. The checkout component, if you check on an order, could say, hey, there was an order placed. That's an event. It's published on the bus. It has no idea who is interested in that. Then the payment service probably picks it up and says, okay, there's payment to do, so I collect the money, and then I say, okay, the payment was received. Then the inventory could say, oh, payment received, so I have to collect all the goods. And when I did that, the goods are fetched. The shipment knows, because there's an event, oh, no, I have to ship the goods. And this is actually how you can see a lot of systems developed at the moment. If you're looking into truly event-driven microservices, this is what you very often see there. What's actually quite obvious here, if you use these, I call that peer-to-peer event chains or peer-to-peer communication, what you can already see on that picture is that it's, you don't see that overall order fulfillment process anymore. It's not there. You just have a couple of components who know which events they emit and which events they are interested in on. So it's really hard to see that flow, and it's also really hard to change that flow. And I already recognized that a couple of times over the last 2 or 3 years when I was at customers. But I was really happy when Martin Fowler wrote that blog post, which I referenced here. Jakob had that on the slide yesterday as well. And he wrote basically the same thing. So it's very easy to make nicely decoupled systems with event notifications. That's why people are doing it. But without realizing that you're losing sight of a larger scale flow, and thus set yourself up for trouble in future years. And that's not where you want to be in future years, right? So that's kind of the big risk here. And we also see that in the survey, by the way. So the top, I only want to highlight the top 2 answers, which are the lack of visibility of end-to-end processes that span multiple services. That's the big thing. And also, like, a lot of errors might be at the boundary between 2 services when they communicate, because whatever, the message is lost or whatever. And that's quite a big problem. So these are the challenges you now have to face. Again, I actually wanted to put that in pictures. And what you see, what the people are envision with these choreography, with these event-driven things, is like this. Normally, you see these dancing people like in a choreography. There's not like a central orchestrator, but they know how they behave, and then it's a beautiful dance. It's easy to spot. It's really a pleasure to look at that. But what I see, what the customers are really getting by doing this, is quite a bit different. It's hard to manage what's going on. It's hard to understand what's going on, and it's sometimes even impossible to change. So that's kind of really a big problem there. And if you look throughout the internet, there's a lot of evidence actually that this is getting a real problem. So I just want to quote Netflix, because they're kind of the microservice pioneers, so it's probably good to quote them. And they also said that, so traditionally, some of these processes have been orchestrated in an ad hoc manner, using PubSub, REST calls, and so on and so forth. However, as the number of microservices grow, complexity increases, getting visibility into these distributed workflows becomes difficult. So they also recognize this kind of a problem. So personally, I think that workflow automation or also orchestration is really an essential building block in these kind of architectures, also in microservices, which is often neglected, and that's a big problem we currently see. And I normally tend to use the term workflow automation nowadays, because orchestration, a lot of people still think, whenever you say orchestration, they think of something like Beeple in the past, or a central huge BPMS somewhere. So it's for a lot of people, it seems to be a horrifying thing, but it's not. So I will go through a couple of examples, and I think orchestration is a very, very important thing in that whole puzzle. And I'm not just saying that because we're doing kind of a tooling for that, but I truly believe that this is something you miss out otherwise. And then you have to balance it out, and I come to examples in a minute, then this gets hopefully much more concrete. On the one hand, you want to have very loosely coupled microservices with a high autonomy of the services, of the teams, and you probably want to have an event-driven architecture, because there's quite some value in that. But you have to look at the business processes end to end, because that's delivering the value to the customer. So that has to happen, and you have to have that visibility. You probably have to meet SLA. So if the order is not shipped within a certain time frame, you should recognize that actually. And you probably also want to improve the end-to-end process. So you not only want to improve like local microservices, and that's a constant struggle. That's hard to find the balance. What we currently do in a couple of projects whenever we see these kind of, for example, event-driven microservice architectures, then we also try to embark on a journey. So the first step could be we only track the flow. We want to make it visible, but we keep everything else alone and still keep the event collaboration going on. So there's some text in that, but that's not that important at the moment. So that's kind of non-invasive, so you just add something, and I make an example in a minute, and then you can basically walk through until you really can manage the flow or orchestrate the flow, but then you have to change things in your architecture. You have to make it much more adapted to orchestration. And then you can have a mixture of orchestration and choreography, and that's actually the place where I think you want to be, you want to end up with. And let's make that more concrete. So if we look back at the architecture, so we have these couple of services, probably choreographed, so sending these events around. What you could easily do is you could take a workflow engine. I had a couple of ideas for products you probably want to use, but you can take a workflow engine. You can just attach it to Kafka, for example, and in the afternoon I'm giving a demo of that. There I have, for example, Kafka Connect, but it could be technically, it could be anything. I just attach it to the bus and read the events. I just read them, and then I can create models, like for example in BPMN, where I say, okay, there are certain events happening. I start a workflow instance, and then I wait for certain events to happen in an order. And then I can already start like tracking what's going on in my system and everything and so on and so forth, which already has quite a value, because what you can immediately do with this kind of architectures, you can attach like other tools you probably want to use, like for example Optimize in the Camunda case, or even completely different BI solutions if you have. So you immediately start to have data which is really related to the overall flow, which is kind of a very important thing. So that's kind of the first step you could do, and that's totally non-invasive, so you don't have to change a lot actually, you just attach it to Kafka. And that's really easy to do, at least as a POC, that you don't have to change anything. But it's very limited in power. I mean, now you can look into it, that's already a good first step. But what we easily can do then is we can attach certain things, like for example, we could say whenever the goods are not shipped within whatever 40 days, 21 days, probably in the Zalando case it's more like 2 days, or 1 day, or 12 hours, then I can do something, I can start acting on something. The motivation for these kind of things, like whenever something takes too long, is very easy, because normally you don't have other places in the architecture which can really monitor that. And so you can easily start acting on something. And then the engine is not only listening, it's starting to do something, it's probably changing something. But that's very valuable. There it's easy to deliver value pretty fast. And as soon as you start going down that route, we're basically moving on that arrow I had earlier. I mean, moving from track to manage, slowly to the right. And then you could also ask yourself, okay, why I'm not doing more? I start to do something, I start to orchestrate. Okay, so this if I send some messages, if I command somebody else to do something, that's orchestration. Let's make another example. So let's assume you want to change the overall flow. Sometimes you probably want to adjust business processes because whatever happened in the outside world, in the markets, you want to change that. If you think about, in this case, you simply want to change the order of payment and goods fetching, which could be because you probably want to ship faster, or you want to make sure that the goods is really on stock before you retrieve the payment or whatever. So you simply reverse or change the sequence of steps. If you want to do that, on the left, what you have to do is actually, you have to change, in this case, 3 event subscriptions. If you're doing REST, you have to change 4 services because they now have a different order. I actually like this effect very much. So I think it shows very good what problem you have, because that's a 3-leg trace. And in this case, you even you bound together 3 or 4 services, you probably have to deploy them at the same time, because if you change the order, you don't want to end up with orders being shipped without being paid, for example, or the other way around, being paid twice, which is also not that nice. So you probably have to think about versioning. So that's quite a complex problem. And you have to sync between the 2 teams. And that's exactly what you don't want to do with microservices. So there's a problem in here. And it's easy to solve, actually. In this case, it's very obvious. That's why I like making that example. Sometimes it's not that obvious, but it's normally always possible. In this case, I would extract this responsibility of this end-to-end flow, because that's an own business capability you have. You ship orders, you fulfill orders. That's what Zalando is doing. So it should be probably an own microservice. And then this microservices probably also uses orchestration, probably uses also BPMN. In this case, you see we are moving further down to the manage the flow thing, because now we probably still listen to events, we're having this order placed event, that's still coupled by event mechanisms. But then we start to send, we command something, so we say, hey, we want to retrieve the payment, and we actively tell the payment service, retrieve the payment for me. It could be still Kafka there. It could be still asynchronous. It could be REST if you like, but it could be still Kafka. The thing is, and that's a good example actually with payment, I don't want to have payment listening for order-created events, because payment probably retrieves payment for different services. So it's really weird that payment knows about orders. It shouldn't. But orders know we want to have payment, so they can tell payment whatever they need to know or what they want them to do. So that's quite a natural thing. And there you're moving towards that managing the flow. Now we have one really, let's say, ugly characteristic of microservices. If you have microservices, per definition, they are really distributed systems, because the microservices normally live at least in different threads, on your machine, but normally they even live really distributed on the network, different Docker containers, Kubernetes, whatever you name that. But that's a distributed system, and I use that metaphor for distributed systems. Why? There you probably know the fallacies of distributed computing, and the first one is actually the most important. The network is reliable. It's a fallacy. Whenever you use Wi-Fi in the train, you know what I'm talking about. The network is not reliable. And you have to take care about that. You really have to reflect that. And that's why I use that metaphor. So these small hut, for example, that's your one Java program. That's a nice place to be. You have transaction management. It's really threat model. You know what's happening there. It's one programming language. It's awesome to be there. But whenever you open the door, you have the network. And you will have problems with that network, for sure. And you have to plan for that. And that's a huge problem in microservices. And I think so far, most of the people are not really yet understood the implications of that problem. So in our case, just to make simple examples here, so if we have that order service and it has this flow, it could probably still, it could probably still communicate via Kafka, that's what I said, so it could be asynchronous, or if you communicate via REST, you probably should plan for the moment when the payment service is not available, when you wanted to do something, so you probably have to retry for longer times, or you have to wait for a response message. So whenever you have distributed systems, normally these kind of orchestrations, they get stateful. And that's something we see everywhere. So because you have to wait for messages, you have timeouts, you have retries, you have a lot of these kind of things, and this is stateful. And stateful is normally hard to do. That's why it's good if a vendor does something for you. So we have that stateful orchestration there in order. And then actually BPMN is awesome. BPMN is awesome in solving a couple of these problems around what I would call stateful orchestration or integration. So you probably know enterprise integration patterns. There's a book describing a couple of these patterns which are quite common in enterprises. And one of them is, for example, aggregator. So you want to wait for 2 messages to arrive, and as soon as they arrive, you want to do something else. Or you probably want to resequence messages. If I have 2 messages, I want to do something. I want to put them in the right sequence, and I probably don't want to wait forever, so I want to combine that with timeouts. So these are things you can easily model and express in BPMN, and you can run on these kind of engines. And it's a tiny tiny information here, but I think it's quite valuable. So when you look at, for example, CV as a certain BPMN engine, then what we do there, for example, we have time to live for every message. So we can send in messages where the BPMN process is not yet waiting for, and we can say, okay, this should be picked up in the next 30 minutes or 30 seconds. And this makes it really easy to express these kind of situations. So it's really doable in BPMN. Or one of my favorite examples, what I do in BPMN a lot, is compensation. I actually have an own talk on the whole topic of compensation. I called it lost in transaction, because that's what I currently see out there. And I mean, probably most of you are familiar with BPMN, so that's not that hard to read. I say, okay, the payment was requested. The first thing I do is I get some money from the account, from the user, if he has a user account. And then I see if that was sufficient. If not, I charge his credit card. And then it could still happen that the credit card, for whatever reason, cannot be charged. And this, what you don't have anymore in these distributed systems are really technical transactions in a way that you can simply say roll back. It doesn't work. I mean, it's not a technical, you cannot roll back. And that's why I use compensation. And compensation means I semantically undo something. So in this case, okay, it cannot be charged, so I call the compensation, and I define an activity, what should happen when I compensate, so I give him back his customer credit. And this is, again, combined with the problem of distributed systems. So whenever you want to restore the customer credits, it's probably a remote system, and it's not available. So you probably have to wait for that, to have to retry it, because probably the customer wants to have his money back. At least I would expect that. So you see that there are a lot of these kind of problems combined together where I think that for example, BPMN is really, really powerful. And then one of the important thoughts, I discussed that so often recently that I wanted to have it here today as well. One of the important thoughts is that orchestration, or also BPMN engines, doesn't have to be a central thing. It's not like there is the BPMS somewhere there. It's like a ugly thing on its own, no. It's probably embedded in your service. So the BPMN is part of the business logic of your service. You could see it in a way that it's an implementation detail that you use BPMN. I mean, you also use a database, you use other frameworks as well, but you don't expose that information to the outside. The service has an interface, like retrieve payment, and then it does something. And because that needs stateful orchestration, they probably use BPMN for that. And this is the way I look at that in microservices. And then you end up with probably a lot of BPMN in different services, and they are very independent of each other, so you don't have a monolith BPMN. That's one of the bad practices you could do. Then normally the next question is like, okay, you have these multiple BPMN files. Do you run multiple engines? Is that what you're saying? And there are actually different options to do that. So one could be you still run a central workflow engine, like especially with CB, for example, that's possible, but also with Camunda BPM, that's very fair. So why not? You save a lot of effort probably in operations. For me, the important thing is that even if the BPMN file then is deployed on that central workflow engine, it means that it's still owned by the order service. So there should be the team in the order service should model it, should change it, should put it in Git, should deploy it whenever it's appropriate for them. So they really own the model. And if you have other models, and they are probably deployed on the same engine, but they are owned by a different team. And the ownership, the governance, that's the important point. For me, that's the most important point to focus on. And then you can run central engines. There are advantages and disadvantages. You just have to discuss the forces. So I don't want to do that here today. But there are reasons for the one or the other. So that's something you have to decide. If you decide for a decentral engine, hey, that's fine. That also works. And then you have total autonomy. The team can even decide for the technology. They could use different engines, different vendors if they like. That's fair, doable. You can do the same thing. I focused a lot on messaging and event-driven stuff, but you can do the same thing with a REST communication or gRPC or synchronous request response. That's the same thing. And I know that still, like I would say, 70 to 80% of our customers, at least, are still doing REST. So most of them are not doing event-driven Kafka architectures. But if you're doing REST, you have the same problem. You're just switching the communication direction. There are a couple of things which go different, but basically the same thing. There you can run a central or decentral engine. One of the main questions normally now is if I discuss that, decentral engine, people say, okay, that's actually what we want, that's cool. But how do we do monitoring? How is that? Now we have these, like in Camunda case, 2 cockpits. How does that work? And what we normally do, and we have a couple of customers who do that, and we also have a code snippet showing that, it's very easy in the engine to also emit a couple of events, like I started a workflow, I completed an activity, and so on and so forth. And then it can easily also build like a second component, catching these events and storing them somewhere, which is normally something around Elastic, for example, the Elastic Stack or so on. But that's normally what the customer do, and they already normally have something in place. And then you could there just show the overall information and probably link back to the right cockpit in order to go to the details. And then it's even an advantage, because if you think about the DevOps idea, it means that the team really caring about the order service also cares about the running the order service, but only the order service. So it's probably for them it's cool if they have a cockpit where they only have the order service. So it could be an advantage. And if you look at our stack, for example, Optimize already works that way. So in Optimize you can feed in data from multiple engines, and we probably also improve this stack in other places for doing something like that. So that's basically not a showstopper for the whole idea of having decentral engines. There's one last interesting thing to look at. I'm almost done, but one interesting thing to look at. So if we come back to that architecture, one last way of using the engine, which we also see at a couple of customers happening for microservice orchestration. They use it as kind of, I normally name that work distribution. So they have the workflow engine. They say, okay, the checkout service there, for example, starts a workflow instance. And then the other services getting tasks from the workflow engine, like if you know Camunda BPM, it's like the external task pattern, for example. And then the workflow engine is kind of the communication thing. I don't propose that as best practice architecture. That's not what I'm saying, but I see that happening pretty successfully, actually, at a couple of customers. And what I actually see happening the most are hybrid architectures where they use a bit of everything. So you probably have RabbitMQ for asynchronous communication and subscribe to certain events. And then you probably start a workflow instance, and then you have like external task thingy, work distribution, and probably even like synchronous REST calls, which is still do. And the cool thing is that if you get that together in that stateful orchestration part here, you have a lot of power in order to do that, because you can wait for messages, you can also like publish tasks in that external task fashion, or you can call REST services, do stateful retries, do the cleanup, do the compensation. There are a lot of things you can really do there. So a quick recap. So I think microservices have its merit, so it will not go away. That's what I currently think. You really have to think about balancing orchestration and choreography. Both have value, but you should combine that. You probably need stateful orchestration because you're in that distributed system. Visibility, I think, is one of the essential things. We discussed that yesterday in the panel. So you really have to see what's going on in order to really manage it. And that could be that fat arrow, right? From tracking the flow, you probably advance to really managing the flow. And obviously, workflow automation is quite important for that. And I would make sure personally that you're using BPMN. I'm really caring about. I think it's definitely a good language for that. Even if you use different tools, probably, but make sure you're using BPMN. I think that's a really good thing. And then it basically takes place everywhere in the adoption journey. Daniel showed yesterday, I actually made my own slide on the adoption journey because I think it's a bit more realistic. But everywhere you have these kind of microservices. So in the technical workflow implementation, you probably need just help to do that distributed system stuff, and it goes up really to have these like distributed orchestrations with BPMN and different services really to support the prod scale adoption and these kind of things. That makes a lot of sense. If you're normally people ask, okay, this is what you're doing with CB. No, that's not necessarily CB. It's also totally valid for Camunda BPM. So we do that with a lot of customers with Camunda BPM, probably also with CB. I'm showing a couple of these things in the afternoon with CB. I have actually all the code for the slides I have on GitHub, so I have code as well. I'm not supposed to show it here today, but probably later on I do a demo there. That's all I have. Thank you very much. There are a couple of links if you're interested. If you have any questions, ask me later on. I'm here the whole day, so I'm happy to discuss everything. Thank you so much. Enjoy the day.